In this video, we're going to talk about covalent compounds. If you recall, compounds are pure substances that are going to contain two or more elements, and those elements are going to be bonded together. We have different types of bonds. So within a covalent bond, we're going to have two nonmetals. All right, so there's going to be two nonmetals that are sharing electrons. So that's how the covalent bond is formed. Now, the electron orbitals of each atom overlap. So here are a couple of examples. We have two hydrogen atoms on their own. And then when they become a compound H2, we have these two orbitals overlapping. So this would represent the 1s orbital, and this would also be the 1s orbital. Now there are electrons in here that are being shared between the two hydrogen atoms. The only way you can get those electrons to share is if you have the overlapping orbitals. In this next example, we have hydrogen and fluorine. So this would be a 2p orbital of fluorine. This is the 1s orbital of hydrogen. They overlap, and we have our electrons in there that are being shared between the two atoms. So the big thing with a covalent compound is these are compounds that are held together by sharing of electrons. A lot of us have heard the term molecule before, and a molecule is a covalent compound. So it doesn't apply to all compounds. It is only a covalent compound, which are made up of nonmetals that are sharing electrons. Oh, something I want to add here, just to be clear, is this can be two or more. All right, you don't just have to have two. You can have compounds that have lots and lots of nonmetals, lots and lots of atoms in them. So let's look at naming a covalent compound. So when you're naming a covalent compound, the first thing you want to do is name the first element within that compound. And then the next is you're going to name the second element, but change the suffix to "ide." Now, if you have more than one of that type of element, then you're going to include the Greek prefix, and this indicates the number of atoms that are present. You do need to know this table for nomenclature, and nomenclature is just a fancy word for naming. Now, all of the naming that we are going to be using in this class is IUPAC nomenclature. So on one of your quizzes or a lab, make sure that you are using the IUPAC nomenclature. If you Google a lot of these names, you'll see there are all kinds of common names. There are all kinds of different names for these different compounds that we will come across, but you only get credit for naming them using the IUPAC rules, which are given right here, 1, 2, and then the bullets. So let's look at some examples of what this looks like. So the first thing I'm going to do is identify what elements I have in my compound. So for this first example, I have N. I can look on my periodic table, and I know that N is nitrogen. So my first step is to name the first element, nitrogen. My second element is capital O. So I can look at my periodic table and I can see that it is oxygen. Now, this is a little bit different because I have two of them. And also, since it's the second element, I need to change the suffix to "ide." So I can change my oxygen, and I'm going to take the suffix, which is just a fancy word for the end of the word, and I'm going to get rid of that end of the word, and I'm going to replace it with "ide." So this becomes oxide. Now I have two of the oxygens, so I can go to my table. I can look at the number 2 as the prefix di. So when I name this, it's going to be nitrogen dioxide. And these are two words. My got kind of scrambled together there. All right, so it is going to be nitrogen dioxide. So this means that I have one nitrogen and two oxygens. All right, let's look at this next example. S is sulfur, and then I have oxygen again. So I only have one sulfur. Notice there is no subscript right here, so it means there is one. Remember, we never write the subscript 1. So this would be sulfur. I have 3 oxygens, so I can look at my table. I need 3, so I'm going to use the prefix tri. So it's going to be sulfur trioxide. If you look at the table, you'll notice that there is a prefix for 1. It just is really not used. The only example where it's used is carbon monoxide, and that's just because it is so common these days that it's always used. But for every other compound, you will not use mono or mon for 1. So notice I did not write mononitrogen dioxide or monosulfur trioxide. I just wrote nitrogen dioxide and sulfur trioxide. So go ahead and pause the video, get some practice with B and C, and then you can come back and we can do it together. All right, let's look at these together. Now, for this first one, I notice that I have a prefix for my first element. And my first element is P, capital P. So when I look at the periodic table, I see that it is phosphorus. And I can go look at my nomenclature table right here. 4 is tetra. So when I write this in, the first element given is just the name. So this is going to be tetra phosphorus. And then my next element is oxygen, and I have a subscript of 6. So I need to use the prefix 6, which is hexa, in order to show that there are 6 oxygens. So this would be hexa oxide. So tetraphosphorus hexa oxide. Notice that there are no metals present in any of these compounds. So if you see a metal, you don't have to use the prefixes. The only time you will use the prefixes is when you are naming covalent compounds. All right. We can look at our periodic table and see what AS is. What is AS? Yep, you got it. It is arsenic. So we can name our first element. Notice I only have one of them, so I can just write arsenic. And then I have 5 chlorines. So I can look at the prefix for 5, and it is penta. Now, chlorine, the suffix is the ine. So I'm going to take off the ine and add ide. So it will be pentafluoride. All right. Now, when you are taking the names and trying to figure out the formulas, it can be a little bit easier. First of all, these are not ionic compounds. I apologize for that. This should say covalent compound. For this one, I'm going to look at what the prefix means. So hepta is 7, and I'm dealing with silicon. So for my formula, I'm going to have Si, and since I have 7 of them, I'm going to write the subscript 7. Now, in my next element, it is oxide, so I know I'm dealing with oxygen, and my prefix is tetra. So I'm dealing with 4 oxygen, so I can write O4. So heptasilicon tetraoxide is going to be Si7O4. If I go over to carbon disulfide, I just have one of the carbons, so I can look at the chemical symbol for carbon is capital C. Sulfide is sulfur. I know that symbol for sulfur is S. That is so bizarre. I've never seen that happen before like that. There we go. And since it says disulfide, that means I have 2 of my sulfur. So carbon disulfide is going to be CS2. Go ahead and pause the video, see if you can do chlorine trifluoride and diboron hexachloride on your own. Come back and we can do it together. All right. So for this first one, we have chlorine and we have fluorine. They are both nonmetals, so I know that I have to have the prefixes. There's no prefix for chlorine, so it means there's just one of them. Tri is the prefix for fluorine, so that means I'm going to have 3 fluorine. So this is going to be ClF3. Diboron, di means 2. Boron has the chemical symbol B, so we're going to have 2 of the boron. And then for my next element, I have chloride, which I know is chlorine, has a symbol Cl, and there are 6 of them. So diboron hexachloride is going to be B2Cl6.